두영서. 네. 정민석 학생은 출장 갔다고. 네, 내가 받았어요. 이메일 받았다고 전해주세요. 네. 형주. 네, 오케이. 제익. 희훈. 성훈. 네. 영인. 재민효는 없죠. 네. 박성우. 세진. 네. 성규. 네. 지호. 승민. 수민. Heung-No. Okay. All right, so let's get started. So we will talk about information today. But before we do that, we have to take care of that one, right? All right, so let's take care of this one. All right. So, where were we? 아, 이게 다시 돌아왔구나. 지금 됐고. 내가 너무 칠판에 바짝 붙어 있으면 내가 칠판을 잘 볼 수가 없어가지고. Okay, so we are considering Monte Hall problem, and then I was supposing there was a car behind the first door. Okay, I told you that this doesn't change the problem, but still we have to justify it. That's one problem. And then after that, then we were considering this, right? Total probability theorem. Okay, so let's take care of the first one first. Okay, so presupposing there is a car behind the door number 1. We think it is like so, right? But can we make it exact? Okay, that's the objective. So for that, let's define a random variable. Let's say P. P is a placement of a car behind the 3 doors. And then this is a random variable from the set of what? Set of what? Doors to the numbers, right? Door number 1, door number 2, door number 3. So this is a random variable from this space to that, okay? And then we let the probability that P is equal to I. 이게 좀 안 좋구나. P라고 하니까. So let's change it. Okay, let's change because we have to say the probability too. So P is a reserved letter. So let's say because Monte Hall does this. Let's say M. M is the placement random variable. So then after that we need to define the probability. So probability that M is equal to I is equal to what? What do you like? 1/3, right? Equally likely, right? For all I. Then we are done, okay? Right? And our objective is, we can suppose any place because it's going to be the same problem, right? Let's make sure that, okay? Then the probability that we want to find out is this. Again, this, right? And then I want to condition upon the placement, okay? Which is the random variable M. So I use. How do you do that? First one, total probability theorem again, right? So probability A is equal to 1 and M is equal to 1 and so on and so on. But we don't want to repeat. So do this sum of all I running from 1 to 3. I can do that, right? And then, this joint probability. Now I'm going to condition it. Am I okay? But actually, you have to write down the joint first and then do the next line. But I'm kind of sloppy, okay? Sloppy on the board, okay? And since this become a conditional probability, right? Now you can think of 3 cases, right? Probability A is equal to 1, given M is equal to 1, right? And then probability, I say, is equal to the same as this. I say this. This is a claim. Do you agree? You're smiling. Why? 한국말로 해.
어글이라고 답변해야 될 것 같습니다. 집중을 못하고 있었어.
집중을 못하고 있었어? 웃길래 또 뭐 재밌는 일이 있는 줄 알았지. So, do you agree with that one?
네, 거의 그런 것 같습니다.
Why?
플레이스는 3분의 1로 동일해서.
Yeah. So, for example, let's say we move this to here, and then there's a goat here, right? As far as concerning A is equal to 1, is it going to change anything? It's just changing the index, right? If I place this index right here, just name differently, then it's exactly the same argument, right? So that's the case. And then basically I can do the same with the probability that A is equal to 1, given M is equal to 3. So all of them are the same. Okay? Then in this summation, what I can do? This one is not dependent upon the argument. Then I can place it outside. Then 3 times addition of 1/3, which is 1. Then this becomes what? Same as this. Then this becomes same as this, okay? That's what I'm presupposing here, okay? So in fact, if I have to be exact, then basically this is the same as probability that A is equal to 1 given M is equal to 1. That's what I'm doing. So if you are very critical about the notation, maybe you can change this. No, this is not that problem. I'm going to let that this is equal to M is equal to 1. Okay. Just a survey argument. When you write a paper, okay? So, but in terms of probability, what I'm actually doing is this. But in word, I say, suppose that there was a car behind door number 1. And then I solve a smaller problem. So that I can concentrate on the part that is more important, okay? All right, so that's that. Having said that, I can erase this part. I can erase this too. All right, so let's consider option number 1, stay, right? In order to entertain that, I have decomposed into 3 terms using TPT argument, right? So far so good, right? And then I consider the first one. This one is a staying option, right? So staying option. Then this can be written this way, right? That first one can be written this way. I mean, I consider the first one, that's what I'm doing. A is equal to 1 and X is equal to 1. And then that using the conditional probability is this, right? And then this one I know, which is 1/3, right? How about this one? I'm not sure, so we do one more time, right? A is equal to 1 given x1 is equal to 1. I want to do this. Now expand it, this one more time. But when I made this decision, right, what does Monte Hall do? Monte Hall will open up a door for us, right? But what kind of door, I mean, which door Monte Hall does open? Monte Hall was the one who placed car behind the door number 1. So he's not going to open up door number 1. Not going to, right? So he's going to open up either door number 2 or door number 3. That's what Monte Hall will do. Okay? All right? Then that's what Monte Hall opens up either one of the 2 doors. Okay? So just for the sake of argument, let's suppose that door number 2 was open. Okay? Do you think if I change it with the door number 3, that will change anything? Same thing. So let's just assume this. Okay? Then this one can be written again in terms of x2. This can be written this way. x2 is equal to 1. Okay? Given x1 is equal to 1. Plus a is equal to 1. x2 is equal to 2. x1 is equal to 1. Last one. I can do this, right? I haven't done anything, just TPT again, right? TPT again, right? And then what I can do? So first one, I can, this is too difficult for me, so let's condition it, right? So I can say that this is a probability A is equal to 1 given x2 is equal to 1, right? And x1 is equal to 1. Probability x2 is equal to 1 given x1 is equal to 1. I can do this, right? What I have done? From here to here, what I have done? Conditional probability, right? I can do the same with the rest of them, right? So let's just do this. Probability 1, x1 is equal to 1, x2 is equal to 2, x2 is equal to 2 given x1 is equal to 1. And then I'm going to write upstairs this one. Okay, so probability A is equal to 1 given x1 equal to 1, x2 is equal to 3, probability that x2 is equal to 3, x1 is equal to 1. So this is getting tedious, right? But I'm trying to show a case that if you do this tedious work, you can explain and then you can agree to it, okay? And then we can check it. That's the reason that I'm doing this, okay? So having said this, now I can start to entertain. We are under the option of staying, right? So that means, what is this probability? What is this? What can you say about this conditional probability? There are 3 conditional probabilities. Let's say first one, second one, third one. What can you say about it? So let's do one by one, right? How about this? What did you say?
Stay.
So this is a staying option. So what do you think is the probability?
1/2.
1 over 2. So this probability is 1 over 2. There is an opinion. How many of you think this is right? This is what you would do. Where is the other half probability goes? If you allocate half to last one? This one? Ah, I see. So he says, I forgot your name.
이성규.
성규? I'll call you 성규. I'll ask your names many times until I remember your name and your face. Okay, 성규. 성규 says, this is half. 어디냐? 어디다가 했지? 여기다. 안 보인다. Half. That's your allocation. And that's following the staying option. That's what you think. Okay. How about this one then?
Impossible.
This is impossible? On,
Monte Hall opens up D2. So it is impossible.
yeah. So Monte Hall has opened up door number 2 and then has shown that it is a 꽝. 그치? 곧 보여줬어요. So this is, if you allocate any probability here, that will be dumb, right? So you will allocate the probability to this one to 0, right?
What's the X2? Sorry?
Huh?
What's the X2?
X2 is the second selection
Of
of the guest.
gas?
Guest.
Oh.
First selection, second selection. That's the random number x1 and x2. 왜 또 웃었어? So
Why is that? Why is the zero there? Why is the zero? Probably
which one?
that you're sticking out.
Yeah, so maybe since there are questions, maybe we can go a little slower, right? So there are three probabilities. x2 equal to 1 given x1 equal to 1, right? All right, and the probability x2 is equal to 2, x1 is equal to 1, x2 is equal to 3, given x1 equals 1. So x1 is the first selection the guest has made. Given that x2 makes a selection to door number 1. That's what this event means. And then we want to talk about probability of that. Right?
Is that the case that just gas is staying?
Guess what?
The gas choose staying road?
This one?
Yeah.
Yeah, so the first selection was 1, second selection is again 1.
No switch?
So this is a staying option, I guess.
Okay.
We are actually discussing it, right? We haven't agreed, so we are still in discussion, right? I'm not going to tell you the answer, right? Because answer is already out there in the first lecture where you have all the definitions. When you see the definition, you all agree, okay, that this is a good rule. But when you comes down to applying the rule, people have a different thinking, and that's the part that I would like to correct. I shouldn't use the word correct, but I'd like to give you an experience, right? So that you can apply by yourself with confidence. And then if in this process you can make mistake, but you have always tool to resort to, right? Where? Those definitions, right? Am I following the definitions or not? It is going from here to there. Is this supported by any those rules or not? Okay. That's what I'm trying to go. So here, we are under the option number 1. That's the case that we are doing. Don't think about this one yet. We will do it later with a separate, process. Okay? We are under this option, right? In such a case, you are the one who are making these probability allocations. You are the one. Right? This is not given, right? So if you allocate, you can still do this, right? Because it's you that you are making selections, right? Right? But if you have allocated to this one, any probability, any non-zero probability, is it a rational decision? No. So 민석? 성규 says, this should be 0, right? Because Monte Hall has opened up already, and then there is a goat behind it. I have seen it, right? So I will do this, right?
Like there's two possibilities that the host can open door 2 and door 3.
No, I said,
Oh,
yeah. It doesn't matter, right? 2 or 3, it doesn't matter.
really matter, I think. It changed the event space. That's what I'm arguing. Because like.
All right, then hold on. We will proceed with this as is, and then we will consider that later on this one, okay? And then you can verify yourself if it matters or not, okay? All right, so having said that, now you can do, as Seung-Gyu suggests, this, right? How many of you would do this? And then if you do this, is there any problem? Under the assumption that we are investigating? 어때? 영인이? 어때? 말을 해야지. 야. 크게 말해줄래? 다 들리게?
각각이 왜 2분의 1인지에 대한 근거가 있는지.
근거? This is a game. You trying to win the Cadillac instead of goat. 꽝이냐? 100만 불짜리 차를 타느냐? 그거 게임 하는 거거든. You have to allocate the probability. 그지? It's up to you. But we are trying to have a maximum possible probability that you win the car. 그 게임을 하는 거잖아. 그지? 이렇게 할 수도 있어요. 3분의 1씩 할 수도 있어요. 그러면 probability가 A가 1이 될 probability가 maximize 되겠느냐 안 되겠느냐 그 얘기하는 거잖아. maximize 하려고 못해요. 그리고 we have to follow the rule, right? We are under the option of switching or non-switching. But in this case, we are option of non-switching. Okay? So I will just say this, right? And then you tell me. Under our current option, this has to be 0. Why? Because it's not the option that we have chosen. Okay? 그치? Then this has to be what? 1. Then this is what? 그지? stay하고 똑같은 거잖아. 그지? stay means in probabilistically that, okay? That's what staying means in terms of probabilities. Given the first choice was 1, okay? First door. So that's a staying option, okay? So 그러면 then because of that, this part is 0, that part is 0, okay? Then only the part that you have to consider is this, and this probability is 1, right? And then what is this probability now? The first one. This part is 1, right? How about this one? 크게 말해봐. 이름 말해고. 어? 영서 says, what is this?
1/3.
1/3. Okay. 영서 says 1/3. How many of you agree with this? Is it 1/3? Why? 어? 크게 말해봐.
애초부터 A가 1을 확률이 3분의 1이어가지고.
그거는 여기서 we have already incorporated right here, right? We are conditioning, right? So this is the probability of award is equal to 1 given x1 is equal to 1, x2 is equal to 1. And then the hidden assumption again was car is located right behind door number 1. 1이지? 그지? So this probability, you can make mistake, but you can check your answer and then you can self-correct. That's what I'm trying to teach here, right? Instead of telling you the answer, okay? So this become, under this condition, award is 1, right? Because car was located right behind the door number 1, okay? So this type of breaking down into smaller pieces so that we can apply our rules is what we need to do, okay? So 영서 have self-corrected by reviewing our, conditions to 1. Okay. How many of you agree with this one? All right. So under staying option, the second term, third term goes down to 0, right? Only this one stay alive, and the probability is equal to 1. Okay? And then, sorry. So that probability is equal to 1. Okay? And then this one is made of two components, which is that one and that one. And then this part is 1/3. This part is equal to 1. So this first term is equal to 1/3. Okay? So that means this probability is 1/3. This one is equal to 0. This one is equal to 0. Okay? 조용한 거 보니까. 그럼 한 번 더 해볼까? So, next one. Let's do this one and then see if you can follow me. Switch option. Where do we start? So let's erase this. Erase this. Now we are working on this option. Yeah.
터미널로지가 살짝 섞여가지고 이해가 안 되는데 X1하고 X2는
아, 여기가 진짜 빠졌네. Sorry. 그러니까 이렇게 실수해가면서 하는 거야 원래. 안 그러면 여기다가 파워포인트에 다 써갖고 와서 하지 뭐. 그럼 재미 하나도 없잖아, 그지? 생각할 것도 없고. 그냥 이거 답이니까 받으세요 그거잖아. 그거 안 하는 거야 지금.
A1이 그 리워드를 딸 사건을 말하는 거죠?
A1이 지난 시간에 이게 means this event means guest 1 캐딜락 카 그거지. 지난 시간하고 이제 까먹었지, 그지? 이틀 됐으니까. 그러고만. Sorry. 그러니까 어워드가 1이면 캐딜락, 그지? 어워드가 0이면 꽝. 고트. 그지? 염소 받는 거죠. 염소 받는 거 안 하는 거지. 그래서 so in this example, you can see that why we are using this type of shorthand notations, right? Because we can write compactly, right? So that's one of the reasons too. Okay, now we entertain the same problem on the switching option, okay? Forget about the staying option. The staying option, the probability of award came out to be 1/3, right? Under this option, that's the result. Let's consider this switching option, okay? So on the switching option, you have what do you think will be the consequence of this one under the switching option? This one either have to switch into in x2 is equal to 2 or 3, right? So eventually, the probability of award is equal to 1 is 0, right? Because it was correct first time, but second time it switched, right? Then it has to be wrong door, right? Either it ends up in door number 2 or door number 3. So under that condition, the probability of award is equal to 1 is 0, right? You can expect from our first discussion, right? How about this one? So this one you can expect this is equal to 0, but you can make it sure just by what we have done a moment ago, right? Decompose this into the conditional probability, right? Using total probability theorem, then you will see that. How about this one now? So let's take a look at that, okay? So probability A award is equal to 1, x1 is equal to 2, okay? Then in order to incorporate the second selection, you need to do this, right? x2, x1 is equal to 2. 밑으로 쓰는 게 나은가? Probability A is equal to 1, x2 is equal to 2, x1 is equal to 2. I can do this, right? And let's think about this one. Probability A is equal to 1 given x1, x2 is equal to 1, x1 is equal to 2, right? And then probability x2 is equal to 1 given x1 is equal to 2, right? Have I made a mistake? Notational mistake? From here to here, we are fine, right? Who said that? Okay, thank you. 이거 하나 더 있어야지, 이제 이거 잘 찾았어요. 뭐가 있어야 돼? x1 여기 있어야 되네. Okay. Alright, thank you. Alright, that's good. Right. Now, what about this one? Again, this is 1/3, right? And x1 is equal to 2, right? In this case, what Monte Hall does? D3를. So, given this one means the guest has made a selection to door number 2 in the first place. That means Monte Hall does what? He will open up door number 1? No, right? He's Cadillac behind it. Door number 3, right? So,
하나 빼야 되지 않나요? 그 중간에
잠깐만, 요거만 적어 놓고, 요거 하면, 몬티올 opens up door number 3. 요거 써놓고, 오케이. 뭐라고? 네.
스위칭 옵션인데 저 보면은 스테이
저 경우가 뭐죠? 요거?
그 위에 거.
위에 거?
맞아.
아, 여기는 아직 안 하고 있잖아. 요것만 하고 있잖아. one by one, line by line. 생각을 섞어버리면 설명할 수도 없고 듣는 사람도 이해를 못해요. 하나씩. line by line. 그지? A is equal to B, B is equal to C, C is equal to D, A is equal to E 이렇게 가야 된다고. 이거 얘기하다가 다른 거 얘기하지 말라고. 한마디에 딱 하나 아규먼트만 해야 하는 게 매스매틱스야. 그걸 섞기 시작하면 프루버블 할 수가 없어요. 왜? 경우의 수가 너무 많아지니까 안 돼. 그러니까 브레이크다운 하는 과정을 내가 보여주려고 일부러 하는 거거든. 보드에서. 응? 여기를 섞지 마. 여기 갈 때 그 얘기해. 오케이? 왜? 여기다가 기록해놨잖아. 뭘 컨시더 해야 되는지. 컨디셔닝에다가 기록해놨잖아. 그러니까는 안전하단 말이야. 생각을 한 라인에 한 가지 생각만 하면 된단 말이야. 그거를 지금 말하는 거다. 오케이. 어디까지 했더라? 어디까지 했냐? 가만있어 봐. 아, 요거를 하면, 몬티올이 도어 3를 오픈했다는 게 이제 나오는 거지. 그럴 수밖에 없지. So that's what Monte Hall has to do. Monte Hall has no other option. 그지? door number 3 open up이야. 그지? 그러면 여기다가 probability가 뭐 얼마큼 allocate 되냔 말이지. 스위칭이죠. So this is 1. 그지? 그지? 그런 다음에 이건 뭡니까? 그러면? 얘도 스위칭 했어. 그래갖고 x2가 1이 돼버렸네? 그럼 오버됐네. 그지? 얘는 sure event가 돼버리네. So this becomes a sure event given this. 그치? 그러면 this is 1. 그지? Then this probability, the first one, is equal to what? Huh? 1 times 1 times 1/3. So this is 1/3. 그치? Okay? So now you can do the same with the other two, but the second selection became 2. No matter what does, right? This probability, that probability is 0, right? Rest of them is just a product of this term and that term, right? Either it can be 1 or 0, right? Or in between. But the first one is 0, so that is 0, right? Product of 3 numbers with the 1 number 0 is 0, right? So this is 0, that is 0. Okay? Now I have figured that out that this part becomes 1/3. Okay? How about this one? Just switch the index, right? Does that change the probability? No. So this is the 1/3 as well. So this probability becomes 2/3. That's the answer. Okay. So this becomes the probability. 이거지. Okay. Now this is the and then 이거 하면은 요거 반반씩 섞으면 되지. half and half. 그지? 그러면 여기까지 하면 끝인가? So is this should be the end of the story? 여기까지만 하면 50점이야. 여기까지만 하면 50점이야. 여기 각각에 대해서 길게 설명해. 근데 100점을 맞으려면 어떻게 해야 돼? How do you score 100% from a person like me? 오케이? 그러면 뭘 해야 돼?
기회를 더해서 1이 되는지 해서 이게
아, 검사? 그런 거 안 해도 돼. 이거 다 했으니까. 그런 거는 저기서 하는 거잖아. 저 학부에서 하는 거야. 학부 교수님들은 그런 거 이제 막, 나는 그런 거 체크도 안 해. 말로 정리를 해줘야 돼요. 왜 그런지. 여태까지 이런 과정을 겪었던 거는 지금 이 한 마디 두 마디를 정확하게 하기 위해서 한 거야. 확신을 갖기 위해서. 그러면 뭐야? 말로 정리를 할 수 있는 사람. 지금 이 결과를. 해봐.
바꾸는 게 낫다고 써주면 되는 거예요.
아, 그게?
바꾸는 게 좋다고 쓰면 되는 거예요. 마지막에.
바꾸는 게 좋다. 오케이. 그것도 바꾸는 게 좋다. 바꾸는 게 좋다. 오케이. 바꾸는 게 좋은데? 왜 그런 거야? 왜?
아까 저희가 한 거에 의해서.
그러니까 한 거를 설명해 달라는 거지. 말로. 응. 뭘 해봤는데? 그러니까 the first one was what? The first one I was getting the probability of 1/3. 그지? And then I was relying only on the first option. 그지? First option was the guest able to incorporate Monte Hall's decision to open up a door? No, that was not incorporated into his decision. 그지? 몬티홀이 열어서 보여줬네. 꽝이라고 보여줬는데, 그지? 근데 그거를 probability assignment를 저런 식으로 안 바꿨잖아. 그지? 몬티홀이 오픈해서 보여준 게 뭐야? 나보고 probability allocation을 바꿔보세요 한 거거든. 저거 하라고 한 거거든, 저거. 이거. 몬티홀이 오픈업 해서 하나를 0으로 보내버릴 수가 있었잖아. 그러니까 슈어 이벤트로 갔잖아. 더 이상 게스가 아니었잖아. 그지? 하나를 열어버렸으니까. 그지? 세컨드 옵션은 몬티홀이 오픈업해서 보여준 그 정보를 활용해서 probability assignment를 내가 스스로 만들어낸 거잖아. conditional probability를. 그지? 얘는 그냥 1/3, 눈 감고 그냥 찍은 거잖아. 그지? 그게 staying. 근데 얘는 오픈업 하니까, 저런 일이 생기는 거를 알아채고 바꾼 거잖아. 그지? 그거를 설명할 수가 있어야 돼.